Uh, Today we're going to talk a little bit about doubly linked lists. You're going to see them again later on. What I have in front of me currently is a singly linked list. Basically, you have a node which can contain any number of things. In our examples, they just contain integers. But they also have a next that points to the next item in the chain. Now, a doubly linked list has a previous as well, meaning instead of just going to the next, I can go previous to the previous item. It doesn't have to just be, the next. I can go next, next, previous, previous, next, next, just go back and forth. So this kind of allows me a little more versatility to go back and forth. As far as coding goes, though, it really doesn't change a lot. There's a few extra little things we have to change from our original linked list code, which we're going to be using as a base. But you'll note, because I'm going to put them basically on top of each other and go back and forth, uh, the differences are really just a handful of lines to add this functionality. Now, as a side note, if I needed a circular linked list, which basically means instead of this pointing to null, which is normally what it does at the end, it would point back to the front. This, if I had a previous, would point to the back. So basically, I would make this big circle no matter which direction I went. That's a circular linked list. We're not going to make one of those, but just so you know the idea. The last pointer would point to the front. The previous, if there was a previous, would point to the end. And that's effectively how that works. Now, for this project, what you're going to need to do is open up your linked list, make a new project, and basically just copy everything over. Copy the node, copy the linked list, and just make a few small adjustments. So one of the big things here, difference-wise, this is new. The previous. And of course, the previous here. Everything else is exactly the same in the node. The only difference is we're just giving it one more attribute. So again, this is node. Now, the original linked list I'm going to have here, followed by the doubly linked list, which is this one here. And I'm going to go back and forth and show you the difference. Makes it easier to make adjustments. So, first off, let's take a look. We have, of course, node head, list count, head to the front. If I wanted a tail, that would point to the back. I'm not going to bother putting one of those in there, but just know that, head, front, tail, back, that's general terminology there. Uh, Now, so far, this is my singly linked list and my doubly, and they're pretty much the same, right? There really isn't a lot of difference that we can really discuss here, uh, at least initially. So let's take a closer look here. Uh, I'm going to look at linked list. There's this heading portion here. All that is the same. Take a look. Same. Now I'm going to move down to, and I have a couple of extra little items here, like insert last and things like that. I don't have those in every project. Let's see. If I do, I'll show it. Let's see. I do have insert last. So I'm going to scroll down to insert last on both of these trees, or both of these programs here. So there's insert last. And as I scroll back and forth, well, between the proper programs, there we go, uh, you'll see there is a couple of little lines of difference. Basically, to add a previous, we just have to adjust that one pointer. Inside insert last, there's only one line you have to add, right there. And I've taken the liberty of highlighting it for you. This is new. N.previous equals temp. So basically, you're just pointing the previous variable to the previous thing. This insert last puts it at the end of the list, and basically just, points it to whatever the previous one was. Now insert first does exactly what that states. We insert first. Make sure I line it up. There we go. And if we go back and forth, let's close this out real quick. There we go. Well, that's fine. Boop. Now, take a look. Insert first. One line of code is added. This line here. And again, I highlighted it for you. You should already have the linked list written from when we did it previously. Now, your regular insert for your doubly linked list and your singly linked list, your regular insert. This has a little bit more to it. So you'll see if I click back and forth, there's actually a couple of things that we've added. So let's take a look here. And I'll zoom in a little bit here to help. All right, so the things that we're adding. Well, everything at the beginning of insert is the same. If it's 0, well, there isn't a node to add, so it doesn't really matter. Previous is already going to be null, so we don't really have to adjust that. If the number we're looking for is greater than the number, or the number we have is greater than the number we're looking at, then we go to the next one. We make a little adjustment here. This means that we're going to put it wherever it needs to go. So let's take a look. Head.previous equals n, that's added in there. So what we're doing here is just making sure the previous connects to the previous node if there was one. Now, this would be assuming basically it goes to the front of whatever we're doing. So let's see if temp.getNumber is the number we're looking at is bigger than the number we're trying to insert. So that means the very first number we look at is the biggest. This goes attaches to that. So I'm going to take the temp and I'm going to point its previous to the new thing. That's basically what's happening there. So it has to go in the front. That means to connect the previous, the first one's previous, which was null, points to it now. All right, if we go to the next one, well, that means it didn't go in the front, it goes later. We loop until we figure out where it is. And we don't need the previous for this. We just keep the normal next, 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 next until we find the location it needs to go. Now, when we find the location it needs to go to, we apply the next to point to the next one when we're trying to insert it. And we have to do the previous as well. So if we take a quick look at my paint example, I want to insert a node in here somewhere. Let's say it's supposed to go there. Well, what that means is this previous has to point to that now. Well, if it would allow me to move it. You kind of see how that works? Let's see, can I? There we go. This previous would point to this. This next would point to that. And then this one's next would point here. This one's previous would point there. That's effectively what we're doing with a doubly linked list. We're inserting it and we have to, instead of just juggle 2 pointers, juggle an extra one. Now, let's see here. Back to insert. Now, we've added that in. Now we have this extra line here. If n.next does not equal null, n.next.previous equals n. So n is here, n.next goes to the next one, n.previous comes back. So basically it's just saying the next item's previous now points to the new node, assuming we're not at the end of the list already. Basically what this is stating is just what I just did actually. If I can get to my paint to properly pull up, there we go. I'm inserting it here. If the next is null, well then that just stays null. If it doesn't, I have to go to the next previous pointer points to this. The next one points to that. That's what that line's doing. It's making this node over here the previous point to this. Now, and then everything else is roughly the same, just those few new lines there. Now we scroll down to delete. We'll take a quick look at that. There we go, delete, and delete. Now delete for each of these. Let's take a look. Now just like with adding something, now we have an extra pointer we have to remove as well. So if you want to see the major difference here, tick, tick, tick. There's a couple of lines we're going to have to add here. One, we're adjusting some previouses and things like that. Head.previous equals null. Head.previous.next equals null. And then we go down to the bottom a little bit more, and we're adjusting another pointer, removing it basically, or pointing it to another thing. If you remember how linked lists work, effectively if we want to delete something, I want to get rid of this thing, well then I have to adjust the pointers for these. That pointer points here. This pointer now points here. Like that. So we're not really deleting the node so much as we're just pointing the pointers away from it. And Java's default operation with the garbage collector will basically go and remove it because there's nothing pointing to it or referencing it anymore. And again, I know some of it's somewhat complicated. That's why I'm not asking you to write the whole thing. I'm just asking you to kind of understand how it works. Now, this is our delete. As you can see, there's just a couple of lines that are different, 3. I'll hide that. Now in the original, look like this. Now I have a couple of extra methods here that I'm not going to show you, but unless you request it. And I keep clicking on that. Go back. There we go. So here we are. I have find, which allows us to find something in the linked list. Now, interestingly enough, there is basically no difference here between linked list and find. If I'd line them up appropriately, you'll see there is absolutely no difference because we're not really using the previous to find it. We're just going in one direction. Show all, same thing. It doesn't really matter because we're not really going to be using it. It's still the same. Like that. And getHead is the same as well. The little getHead method. Now, if you're interested, I've also got a method here to sort. We talked about different ways like if insert first and insert last and delete first, delete last, these types of methods. What they will do is they will effectively just, make it so it's not in order anymore. What we can do is add a method that sorts it. Everyone in this class should have already gone through sorting, so you kind of know how that works. But take a look. Basically what I do is I take the node, I make an array that's the same length as the list, and then I go through and I put all the numbers in the array. Ta-da! I empty out my linked list, and then I will go back in and, sort it. Start the sort is inside. Let's see. Insert is the sort. Now, actually, I don't have to sort it because, or using a sorting algorithm or anything like that, because what does a linked list do? It inserts it in order. We've already actually created our linked list to work that way. I mean, you could use a sorting algorithm if you wanted to. There's no point. It doesn't matter what order I insert my numbers in. basically what's going to happen is they're going to go in sorted order anyway, because that's how we built the linked list originally. So all I have to do is just take the numbers out, put them back in, and whatever order they were in, they're going to be in sorted order, because that's how our linked list works. And that's what this code here does. Now I'll scroll up so you can see it from the beginning. I'll even show you a couple other methods I have here. Linked list, insert last, insert first, insert, probably our longest bit of code here. There. I have a delete, which deletes things from my linked list. And I've added these lines here. I also have an extra delete, though I don't recall quite why I have that extra delete. As far as coding goes, I think there's a slight bit of difference. Let's see here. Node temp head previous equals null, while loop, while loop. The only difference is the list count, I think. No, that's the same too. Oh, I know what it is. Okay, never mind. This returns what I delete instead of just being a void. So basically, it's the exact same thing. This removes it, and then we don't see it again. Int delete, which is this here, allows us to actually get that number back once we remove it. We can put it somewhere else, and that would be here. If you wanted to return it for whatever reason, this is what it would look like. Now, I do have a delete first. If you want to delete the very first item in the list, there it is, in all of its magical glory. We already know the head, we just adjust a couple of pointers. Delete last, same thing. We go to the end of the list and when we remove it. That's it. There. Find allows me to go in and see if something is in the list from there to there. Show all displays, and this is a print here, not a print line. Everything else is print line. Get head and sort. And that is doubly linked lists. Aren't you happy we don't have to write circular linked lists? That would be a whole nother set of pointers we'd have to worry about. The end and the front would just have to be rearranged every time something went there. It wouldn't be a massive headache, but pointers are confusing enough as it is. Adding more makes it even more so. All right, I hope you enjoyed that, and see you later.